Lesson 4, Day 3, Comparing Numbers in Scientific Notation. Earth is about 1.5 times 10 to the 8th power kilometers from the sun, while the planet Neptune is about 4.5 times 10 to the 9th kilometers from the sun. The distance from Neptune to the sun is about how many times the distance from Earth to the sun? So the first thing that I would do, I always like to do it on my own before I go through the textbook, because if I've done it on my own, it's pretty easy to fill in the blanks for the textbook because you already know what the answers are. And if you don't know how to do it, then them walking you through it is definitely helpful. So for Earth, one way that you can do this is just to from scientific notation to standard form. So that's one way you could do it. So Earth is at 1.5 times 10 to the 8th, which is equal to 1.5, and move your decimal place 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. Adding your placeholder zeros. So we've got Earth is 150 million kilometers away. And then we've got Neptune is 4.5 times 10 to the 9th. So that's 4.5, and move your decimal place 9 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. I couldn't write that on there. So write in your 8 zeros after. Okay. I can barely see this. All right, so we've got 4,500,000,000. Okay, so we can clearly see the distance from Neptune to the sun is 4.5 billion. And the distance from Earth to the sun is 1.5 million. So when we're talking about which one's closer, million is way closer to 0 than a billion is. Well, yes, it is. It's closer to that than a billion is. So we're comparing to see the distance from Neptune to the sun is about how many times the distance from Earth to the sun. So we're really trying to figure out how much farther is Neptune than the Earth. So what we're going to do is we're going to compare the farther distance from the closer distance to the closer distance. So farther to closer. So the one that's farther is Neptune, and the one that's closer is Earth. So you just put Neptune's distance as your numerator. So that's 4.5 billion. Divided by 150 million. Okay, and then you just start dividing. All right, so an easy way to divide, if you know what they mean, is when you start dividing by canceling out the zeros, that means you're just dividing by 10 every time you cancel out a zero. So I'm just going to cancel out these zeros, meaning I'm dividing by 10 every time I'm canceling out a zero. And I'm left with 450 divided by 15. And that's equal to 30. And I know that because I could just do long division, and I prove it. So 450 divided by 15. 15 goes into 4 0 times, but it goes into 45 3 times. Drop down your 0, and 15 goes into 0 0 times. And so I've got my answer. That Neptune is about 30 times as far away from the sun as Earth is. So it's about how many times the distance? 30 times the distance. Okay, and then we'll go through and break it down a different way. But before we do that, I'm going to go into the model it, because the first model it, they did it exactly the way that I wanted to do it first, because I knew it'd be a little bit easier to understand that way. But then the second time is where it's very important. And I'm going to erase this part here so I have a little extra space. All right, so if I knew still, knowing that Neptune is being compared to Earth's distance, then I know Neptune's going to be my numerator. So I had 4.5 times 10 to the 9th power as my numerator. And I should have 1.5 times 10 to the 8th power as my denominator for Earth. So then what I could do is, since I know with scientific notation, we have a number between 1 and 9 as one of our factors, and then a power of 10 is our other factor, I can just break these up. And so then I can say, well, I have 4.5 divided by 1.5 is my first one. So I have 4, my first factor, times my second factor, which should be 10 to the 9th divided by 10 to the 8th. And then I'll just simplify as much as I can. So 4.5 divided by 1.5 is just 3. And 10 to the 9th divided by 10 to the 8th. I go back to my exponent rules. This one's my quotient rule. So when you're dividing powers and they have the same base, you keep the base the same and you subtract the exponent. So that's 9 minus 8. So that's really just 3 times 10 to the first power. And we know that 10 to the first power is equivalent to just 10. So that's 3 times 10, which is 30. 30 times the difference, which I also got up here. So you have two different ways you could do it. You could go back to standard form, which is the way that I chose to do it at first. Or you can do it this way, which I really like this way. It's a little cleaner and way easier to look back and see why I did what I did. Up here was just a lot of zeros, like everywhere. But this made a lot of sense. Both ways make a lot of sense to me, but whichever one speaks to you, you have two ways that you can do it. You can go from scientific notation to standard form, or you can just keep in scientific notation and just break it apart. And break apart your fraction into two factors. Again, our factors were the number between 1 and 9, and then our power of 10. And that's it. Either way, though, you still ended up at 30 times the distance, which is great. But as you can see, I liked doing the second model a little bit better because it didn't take as long, I feel, as the first time, because there's a really easy way to mess that one up. If you just incorrectly put like the wrong number of zeros, you could mess up your whole answer. And I guess the same thing could be said for the other one. If you don't remember how to do your exponent rules, then the second model, it might not be the way for you. But you have to choose what's right for you. All right, and we'll move on to the next page for day 3. All right, number 12. Look at the first model it on the previous page. 4.5 billion is how many times the value of 150 million? 30 times the value. All right, number 13, look at this second model. At 4.5 is how many times the value of 1.5? 3. The way you find that out is you just do 4.5 divided by 1.5, which equals 3. 10 to the 9th is how many times the value of 8, or 10 to the 8th? It's 10 times the value, and we know that because 10 to the 9th divided by 10 to the 8th is equal to 10 to the 1st, which equals 10. Number 15, look at your answers to problems 13 and 14. 4.5 times 10 to the 9th is how many times the value of 1.5 times 10 to the 8th. And we know we can just put these together because 3 is our number between 1 and 9, and 10 is our power of 10, of course, or 10 to the first is our power of 10. So you just put them together. You got 3 times 10 to the first power, and that's just 3 times 10, which is 30 times the difference, or the distance, sorry. Okay, so it says give your answer in both scientific notation and standard form. Scientific notation is our 3 times 10 to the first power, and our standard form is when we just simplified it and answered it or solved it, and that was 30. So scientific notation is 3 times 10 to the first power, and standard form is 30. All right, and number 16, which method of comparing the numbers would you use and explain? So your answers are going to vary here. It's all based on what you like. Do you feel more comfortable going from scientific to standard from jump, or do you prefer to stay with scientific notation? That's your business. That's based on what you like to work with. So I'm not going to answer that one because that's up to you. All right, and then our try it. If you haven't already attempted to try it, please go ahead and pause the video so that you can attempt it and check your answers with mine. It's very important that you try first to see if you're making any mistakes, and if so, what were they? But if you're just copying what I'm writing, it's really not helpful. So please try it, pause the video now, and then come back to it. All right, let's go ahead and review our try it. Number 17, 6 times 10 to the negative 5th power is how many times the value of 3 times 10 to the negative 8th power? Okay, so the way to compare two values that are written in scientific notation is you put the larger one over the smaller and then simplify. So they even says 6 times 10 to the negative 5th power is how many times the value. So we're going to identify the 6 times 10 to the negative 5th as our larger, and then 3 times 10 to the negative 8th as our smaller. And you would know that anyway because the negative 8th power and the negative 5th power, negative 5 is actually bigger than negative 8. So we would know that anyway. So all we're going to do is we're going to have 6 times 10 to the negative 5th over 3 times 10 to the negative 8th. And we're going to break it apart. That's the most important part here when you're doing it this way. Break apart the numbers that's between 1 and 9. And then your power of 10 needs to be different. Okay, so I'll have my powers of 10 here and my numbers between 1 and 9 here. So 6 over 3 times 10 to the negative 5th over 10 to the negative 8th. So what I'm going to do is just go ahead and simplify. 6 over 3 is equal to 2 over 1. And then 10 to the negative 5th divided by 10 to the negative 8th. That's my quotient rule for exponents. So I'll keep my base the same and I'll subtract my exponents. Oops. Minus negative 8. That looks real crazy. All right, that's what we got. Negative 5 minus negative 8 is the same thing as negative 5 plus 8. I just use keep, change, and that's positive 3. So I'm left with 2 times 10 to the 3rd power, which is 2 times 1,000, which is 2,000 times as large. So that's our answer for number 17. Okay, so I simplified it to my standard form, and then I went back to, I simplified it from our scientific notation to get to my standard form so I can efficiently accurately answer my question. All right, number 18. Star A is about 3.4 times 10 to the 18th power miles from Earth. Star B is 6.8 times 10 to the 16th power miles from Earth. Star A is how many times as far from Earth as Star B? So we would know that Star A, since it has the greater exponent, is actually going to be farther away. So same type of thing. Identify which one's larger or farther. Same thing. And which one's closer or smaller. And so you have your farther, sorry for my crazy handwriting, over the closer. So our closer is, our farther is 3.4. Sorry, horrible handwriting. Let me fix this. So I've got my farther over closer, and my farther is 3.4 times 10 to the 18th, and my closer is 6.8 times 10 to the 16th. And I break it apart like I did before. I have my numbers between 1 and 9, and then my power of 10. So I got 3.4 over 6.8 times 10 to the 18th divided by 10 to the 16th. And so I know that 3.4 divided by 6.8 is about a half, or it's exactly a half. So that's a half times 10 to the second power, because I just used my quotient rule again to do 10 to the 18th divided by 10 to the 16th. And I got what I got. And I just subtracted my exponents. So I got 10 to the second power. But then they actually asked me how many times is far. So I've actually got a half times 10 to the second. So you just go ahead and simplify. So we have our, we'd actually have our scientific notation. We need to go back to standard form. So a half times 10 to the second is the same thing as a half times 100, because 10 squared is 100, and that's 100 over 2, which is equal to 50. So how many times as far is star A from star B? So it's 50 times as far. All right, and that's it here. Looks like it says so, but 50 times as far, and that's it for day 3.